Hi, my name's Alan, and I'm going to be talking about a paper called Supporting an Online Investigation of User Interaction with an XAIP Agent. And this is work done with Bart Craenen and Ronald Petrick at Heriot-Watt, and Sara Dalzel-Job and Robin Hill at the University of Edinburgh. And it's part of the Start Making Sense project. So the idea that during interaction, humans use different communication channels that are not only verbal, and if we're going to develop effective XAIP agents, then we should at least understand what these channels are and hopefully learn to utilize them. And the intention was that we're going to do a kind of user study in a lab, but we've had to move online. So during an interaction with an agent, humans might not tell the agent exactly what they're thinking all the time. So in this example, the robot might just have asked, how's it going? And the human's like, yeah, this is great, yeah. And the robot carries on thinking this is great and kind of carries on this path through the spikes. And actually, if they've been able to kind of look at the situation, see the human's reaction, they would have noticed that it's not going so well and might have decided to try a different path. Okay. So we're going to perform a controlled user study, which is going to examine the range of human social signals, effective responses and behavioural patterns exhibited during cooperative joint action. And our task that we're going to set it in is going to be this bike sharing task. So we've got some partial reports of where bikes are, and we've got to go and pick them up. And the idea is to have a bit of a look at what happens with different levels of knowledge difference between the agent and the human. And in this case, we're going to have the agent instructing the human around the map, trying to pick up these bikes. So we've developed an online system, a website, and there's an interface where the kind of tasks done, and behind that's the virtual agent with their behaviour policy, which is kind of part is just a strategy with state action policy that's solving the kind of navigation around the map, and the other part is the explanations, instructions, elaborations, whatever, that are attached to those states. And from the user we then try and gather some observations. So we're taking video, audio, mouse position, and kind of task based observations, and that's all going to get kind of collected at the back end and stored. So the planning problem is a partially observable planning problem. So we get these contingency trees. So for example here, if you're at the tree and you move to the cafe, and if the bike's there, then you pick up the bike. If not, then you move to the house and pick up the bike. And these grow quite quickly. Then on top of that, there's also we want to have an amount of user exploration allowed. So we've focused the user exploration to certain situations where we expect that they might, so for example, ambiguous instructions. There's also a situation where we want them to take initiative potentially, and we also allow just some errors or exploration. But focusing it allows us to kind of keep the amount of explosion limited, and then to kind of try and contract the policy a bit. We're using state matching and we're also because we know the condition that the user is going to be in, there's no point in kind of communicating this big tree to the website, so we prune. So we're planning in this partially observable world, but we actually know where the bikes are, so we can then subsequently prune. So the actual kind of behavior of the agent is captured by these templates that are linked to this to each state, and they provide these different slots for example, providing guidance. So in this case, you're at the tree. The first basic guidance might be move to the cafe, and then if there's a bit of dithering, they might say, oh well, it's red, and if they're still not happy, then you might say, okay, well, we're heading to try and find out where the east bike is, and so in this case the user might already know that it's at the house, and that's the justification they need. So there's a problem with these state-based templates. They're very good for looking forward at what the intention is, what the future plan is. They're not so great for looking back. So in this case, we've got two execution traces. They're at the house. They've just picked up the bike. So the agent might want to say, great, you picked up the bike, but in the top execution trace, they've then moved to the tree and moved back to the house, and they're now in the same state again. So you would not want to say, yeah, great, you've picked up the bike. So there's two ways to deal with this, either by kind of adding tags, extra tags into these templates to kind of cater for different cases, or splitting states. And we've used a bit of both, trying to kind of reduce how much needs done on the website side, just to kind of increase modularity, but in some cases it really has greatly reduced the amount of state splitting needed. So just a quick demo of the website. So this is the debug mode. So you've got the virtual agent on the left top, the live feed and some kind of microphone feedback on the left bottom, and then there's the map and the key. And so first you'll see the basic mode, and instructions, or one of the instruction pages, and then kind of two interactions with a little bit more explanation from the agent.
Go to the pub. Go to the pub. Oh well, that was not the one I meant. Go to the warehouse. Go to the pub. Go to the distillery. Pick up the bike at the distillery. Great. Hi, so you've got some bikes to find. I can help, just follow my instructions. We are trying to pick up the Northern District bike. Go to the pub. Go to the tree. If you can see the bike, then lead the way. Great. We are trying to pick up the Western District bike. Go back to the cafe. Go to the tree. Go to the house. Go to the house. The red one. Pick up the bike at the house. Great.
So in conclusion, we're performing a user study to investigate human response, behaviour and preference in joint task interaction. We were planning on doing it in a lab, but we've had to move online, and we've presented our system and some of the challenges faced capturing an XAIP agent, and we are hopefully deployed very soon, and our future work is to kind of use what we find in a plan-based solution. Okay, thanks.